In medieval Spain, Christian armies rapidly swept across Muslim territories, launching surprise attacks to capture major strongholds like the walled city of Córdoba. Yet, amidst this sweeping collapse, one Muslim city managed to remain unconquered: Granada. Looking at this elevation cross-section, you can see the geographical hurdle that protected it. The massive Alhambra Palace sits safely on a hill 200 meters above the nearest river. But being completely cut off from the valley floor also guaranteed a lack of water. To survive a siege and support a capital, rulers couldn't rely on manual labor. They needed an engineering solution to lift water up the mountainside. This map shows their first major move. Engineers traveled 6 kilometers upstream to a point naturally higher than the palace. From there, they dammed the river and carved out an entirely new path known as the Royal Canal. Navigating the difficult terrain required incredibly precise measurements. They maintained a very shallow, continuous downward slope, allowing the water to steadily coast all the way to the edge of the palace. Delivering the water to the site was only the first step. Without high water pressure, the complex mechanics planned for the inside of the palace were impossible. The palace designers had specific ambitions. They required high-pressure jets, showers, and elaborate water clocks. A flat, slow-moving canal could never generate the force required to power them. This cross-section reveals their workaround. Water from the Royal Canal flowed into an underground pipe, dropping straight into a 60-meter well. Above this, they built a 400 cubic meter pool. A water wheel continuously hoisted buckets up the shaft to keep it full. Storing this volume of water at an elevation higher than the palace pressurized the entire network below. It also gave the city a backup supply of water to rely on during severe droughts. With the system fully pressurized, the water passed over an aqueduct and directly into the center of the Alhambra to power its most impressive feature. Built in the 14th century, the Fountain of the Lions is a functioning water clock. In a timed sequence, a new lion spouts a jet of water every hour to mark the time of day. A central pipe fills the bowl slowly. The rising water hits 12 holes at precise heights, feeding the lions sequentially. After 12 hours, the full bowl triggers a curved internal siphon. Falling water blocks air, creating a vacuum that rapidly drains the entire bowl. In a matter of seconds, the bowl drains entirely and the cycle starts over. They achieved repeating automation hundreds of years ago using nothing but precise calculations and raw fluid dynamics. The water exiting those lines flowed out through shallow ground channels and straight into the thermal baths, passing through an underground wood-fired copper boiler. This cross-section shows the heating loop. Steam from that boiler was routed through hollow channels underneath the marble floors and then drawn up through the core of the structural pillars, filling the room with warm vapor. To dial the temperature in, bathers could control the steam level by opening and closing these star-shaped vents built into the vaulted ceiling. Outside, the continuous flow of water served an essential cooling purpose. As the hot Spanish air blew across massive courtyard pools, the evaporating water absorbed heat, lowering the temperature of the surrounding air. The engineers utilized the palace water supply to power a climate control network that regulated the temperature throughout the complex. There was still one final hurdle. The soldiers' quarters sought completely separate from the main complex, 6 meters higher than the rest of the palace. Hydrating the troops required pushing water uphill. To push water uphill without moving parts, they built this pump. Incoming water swirls into a downward whirlpool, creating a low-pressure vacuum sucking air into the lower chamber. This trapped air creates a lighter, bubbly fluid that incoming water forces up a 6-meter pipe. By manipulating fluid density, they pumped fresh water to their highest defensive positions using no external power. Looking at the entire complex map, you can follow the continuous journey of a single drop of water. It travels 6 kilometers, gets pressurized, times the clocks, boils for the baths, evaporates to cool the air, and finally gets pushed uphill by a whirlpool. The precision required to map all of this out is significant, and many of these medieval fluid mechanics still function perfectly to this day. The Alhambra functioned as an interconnected network. By engineering a reliable water supply where none naturally existed, the rulers of Granada sustained their city for 2 centuries longer than the territories around them.